To understand modern global power, you have to look at something almost invisible to the naked eye. Microscopic integrated circuits, better known as semiconductors, form the base layer of today's digital economy. These tiny chips process the calculations inside your smartphone and laptop. They route signals through 5G networks, manage battery distribution in electric vehicles, and calculate trajectories for guided missiles and drone surveillance systems. For decades, building them required a finely tuned, borderless system. Designers in one hemisphere would send blueprints to specialized factories in another, passing materials across multiple continents with near-perfect timing. Then, in 2020, the COVID-19 pandemic hit. Consumer demand for electronics spiked at the exact moment factory floors locked down and international freight ground to a halt. Automakers were forced to idle their assembly lines because they lacked a 50-cent component for their displays. Across consumer electronics and industrial manufacturing, the supply chain breakdown resulted in billions of dollars in stalled inventory and lost revenue. The shortage exposed a stark reality. When the flow of semiconductors stops, entire sectors of the economy freeze. Controlling that flow has become a primary objective of national security. To see why that flow is so easy to disrupt, we have to map out how a chip is actually made. The process starts with the grains, the architectural design, and software. Historically, American companies have dominated this phase, creating the complex blueprints required for advanced microprocessors. Those blueprints require specialized tools to manufacture. The highly precise equipment needed to print microscopic patterns onto silicon wafers is controlled by a tiny handful of highly specialized firms, located primarily in the Netherlands and Japan. Finally, those tools are shipped to the muscle, the actual fabrication plants. Over the last 2 decades, advanced manufacturing has become hyper-concentrated in East Asia, with the vast majority of production occurring in South Korea and Taiwan. Taiwan is home to the Taiwan Semiconductor Manufacturing Company, or TSMC. This single entity produces a majority of the world's most advanced chips, acting as the primary factory for tech giants around the globe. This global chain is highly efficient, but it leaves the entire ecosystem deeply vulnerable. A disruption at the design, tooling, or manufacturing stage can paralyze the whole network. A country facing a shortage cannot simply build its own local factories overnight. Constructing a semiconductor fabrication plant, or fab, requires overcoming extreme physical barriers. These chips rely on nanometer-scale precision. A single speck of dust can ruin an entire batch. Production must happen in strictly controlled cleanrooms, manned by highly specialized engineers and technicians. Running these facilities demands massive, uninterrupted inputs. A large-scale fab requires millions of gallons of ultra-pure water daily to wash the silicon wafers, plus a constant, heavy draw on the local electrical grid to power the machinery. Then there is the financial barrier. Constructing a single advanced fab today costs between $10 and $20 billion, effectively pricing out all but a few wealthy nations and heavily subsidized corporations. Because building a fab is arguably the hardest, most expensive industrial process on Earth, mastering it provides a level of strategic leverage that very few nations can match. Recognizing this vulnerability, the United States is attempting to pull production back inside its borders. Through the CHIPS and Science Act, the government is allocating over $50 billion into subsidies and tax incentives to encourage companies to build those multi-billion-dollar fabs on American soil. At the same time, Washington has implemented strict export controls. The goal is to restrict China's access to the highly specialized foreign chips and the advanced manufacturing equipment required to build them. In response, Beijing has committed hundreds of billions of dollars through state-backed funds to engineer its way around these blockades. China's objective is to construct a self-sufficient, parallel supply chain that spans from initial design to final fabrication. The primary hurdle for China is the tooling choke point. Because they are currently blocked from acquiring cutting-edge lithography machines from companies in the Netherlands, domestic engineers face significant challenges catching up to the most advanced manufacturing nodes. Meanwhile, India is moving to capture the assembly overflow. As multinational corporations look to diversify away from China, a strategy known as China Plus One, the Indian government is offering financial incentives to establish domestic assembly and manufacturing hubs. though they first have to build out reliable power and transport infrastructure. These industrial policies and trade restrictions are dismantling decades of globalized cooperation. The borderless tech supply chain is fracturing into a series of competing national projects. We are watching a reorganization of the global technology sector. The system is no longer being optimized for maximum economic efficiency. It is being rewired for national security and strategic autonomy. The hardware being hoarded today dictates who writes the software of tomorrow. These advanced chips are the physical building blocks required for training the artificial intelligence systems that will drive the next wave of economic growth. That same hardware will process the variables for quantum computing and power the tracking software inside next-generation defense systems. Leadership in silicon translates directly to military and technological capability. The outcome of this chip war will redraw the map of 21st century influence. It will determine which nations set the terms for future technology, and which must remain dependent on foreign suppliers for their most critical tools.